Hi guys, what do you guys see here? Hopefully you guys can tell that this is just a simple gummy bear, and you do know that gummy bears are sweet, so that means that they must contain some sugar. What else does it have? You can see that it's rubbery, and it's actually made out of just water, some sugar, and some gelatin. And what we're gonna see is what happens when we put this gummy bear into different solutions. So solutions means that they're going to have a liquid and some other compound there that will make it not necessarily water, okay, or not necessarily a certain liquid. So I can have salted water, so that means it's water with salt. I can have a sugar solution, so that means that it has sugar in water, etc. So what do you guys think is gonna happen? If I put this in water, do you guys think it's going to expand or it's going to shrink? Well, let's see what happened. I actually put this, not this one, but I put a gummy bear yesterday, and I put it here. Oh, that's not it. I put it in water, and I left it there for 12 hours, okay? Let me see. No, actually 24 hours, so around overnight. I left it overnight. That is what the gummy bear looks after overnight. So this was the original, and I actually picked the same color so you guys can tell the difference. Is DI water. So DI, for some of you that don't know, that means deionized. So that means that it's not tap water that has some ions that the water plant puts in there. It's not the tap water that we drink. This is just pure H2O, which is the formula for water. It only has hydrogen and oxygen bonded this way. So nothing else but water, and look at what happened. It kind of like, got a lot of water inside and it bursted. It actually was in pieces. I have to pick it up with a spoon. So the water went inside the gummy bear. Now, why did that happen? You probably have heard of a concept that is called osmosis. And osmosis is basically a process where this solvent, okay, in this case will be the water, your liquid, is going to go through a membrane, okay? So basically this, if I actually look at this gummy bear under a microscope, you will see that it's not really solid. It has actually some little, it's porous, so it has little tiny holes in there. So what happens is that water goes through the gummy bear, and it actually goes from a less concentrated solution, which is the water, it only has water, to the one that has more concentrated solution, so sugar. The water initially did not have any sugar at all. The gummy bear has sugar in it. So what happens is that the water goes inside the gummy bear and make sure that then they reach what we call equilibrium. So what happened after overnight, when I saw this gummy bear, the water go in there. Now the color, don't worry about the color, that's just the coloring agent that they have. So basically was able to take some color out. But again, this is osmosis, and you can actually know about that is again in knowing that the solvent will go inside a solution where there's a lot of something else that is not necessarily water. Okay, so I also did something else. Now in this case, what I did was I put the gummy bear in a solution that has sugar in. Okay, so I just put a spoonful of sugar in a beaker just like this one and dissolve that sugar in that water, and I dropped a gummy bear, also red, just for comparison, and I left it there overnight. And this is exactly what happened. Okay, so this has sugar and water. This is the original. Okay, this is just without anything, and this is what happened after overnight. Now you can see that it still held its shape, but it's swollen. So what happened here? The water went inside the gummy bear, but the water already had some sugar in it. So there was an equilibrium between sugar in the water and sugar in the gummy bear. The gummy bear had more sugar in it. So that means that the water went inside, but not as much as here. Remember, this beaker had no sugar at all. So they had to go a lot of inside of that gummy bear to make it balanced. Okay, and here a little bit less. And actually the gummy bear looks pretty cute. It's just bigger. And you can see that it still holds its shape. I was able to just fish it out with a spoon, but it's not like this one that is in pieces. Okay, another thing that I did, I put it in salt water. And this is how it looks like in salt water. I did exactly the same thing that I did for sugar. I put some salt in a beaker and just a spoonful of it, and this is what happened. Now you can see that it's swell, okay? It's swollen compared to what it started from, but it is not as big as this one. And actually it did not disintegrate right here. And why is that? Well, now we have two different compounds that are not necessarily water. This one has salt, and this one has sugar. So mostly what happened here is that something had to, I bet of course if I actually taste this right now, it will have a salty flavor. So because they're not both sugar, the water did not actually penetrate the gummy bear as much as the one that had sugar in it, or as much as the one that didn't have anything in it. Then this is just for fun and see what actually happened. This is with acetone. So acetone, you probably, if you ever see someone that is using nail polish remover, that nail polish remover that has acetone in it, that's what it smells like. It's actually acetone. This is pure acetone. And nothing actually happened. There's no water in it. It actually you can tell because you can feel it, but I'm gonna tell you, I'm gonna squeeze this. This is the original gummy bear, and this is the one in acetone. So it's a little bit harder to squeeze. You actually can see that it kind of like frosty looking like, but nothing actually went in the gummy bear. Now let's look at this one. This one has a solution, okay? So something that is water, but it has something else. It was originally a blue solution, and it had copper in it. And copper is copper sulfate, and copper sulfate is actually blue originally. What happened is that if we have that copper sulfate solution in a sugar that is very small, okay? In this case, it could be fructose, it could be glucose that is in there. And what happens is that copper sulfate, it changes colors. So basically that's what happened. This is not necessarily all blue now. Okay, let me see if I can show it here better. You can see that there's some solid that is formed right here. And it has that coppery color too. And you can see that the gummy bear, and I can touch it because it's not gonna do anything to me. It just changed colors. That tells me, because this changed, that tells me that this has sugar in it. Okay, and this specific sugar, it doesn't have starch, but it has the sweet sugars. Okay. Then the other one that I did, I submerged it in ethanol. So ethanol is an alcohol. It's not the rubbing alcohol. This is the alcohol that is found in alcoholic beverages. Of course, this one is very concentrated. It's about 99% or 95%. And nothing actually went into the color of the alcohol is still clear. The gummy bear is also kind of like hard. So maybe that's one of the conclusions that I can have. And this is, of course, is still super gummy. And the other one that I did, I actually put it in some very concentrated nitric acid. So nitric acid is an acid, so that means that it has some hydrogen in it, and is an acid that is going to be cleared. Over time, when it's exposed to something else, especially air, it turns into this yellow color. So this yellow color did not come from the gummy bear. But I'm gonna show you that, and it's covered because it's highly toxic. The gummy bear is gone. It completely consumed it. So the sugar, the gelatin, everything is right here. And I can see that there's smoke, so I'm gonna cover it again. You can see that some smoke formed on top of the liquid. And you can see that our poor gummy bear is gone. Usually that's what would have happened if I use another gummy bear. It could have shrunk. Sorry, I got another acid, it could have shrunk, or it could have swollen, but just a little bit. But definitely here, and that's what I did, and again, I'm keeping it covered. I did this so I could know what happened. The gummy bear was before yesterday, is gone right now. So again, so I hope that this was a good video where it shows you the concept of what osmosis is. So I really suggest that you try to do this at home. You're not gonna be able to use the nitric acid, but you can try to do it with some DI water. If you actually buy, you can buy at, in the store, you can find distilled water is the same thing. Try it also with tap water and see what is the difference. You can use the sugar, you can use the salt. You might not have the nitric acid, but you can actually have some vinegar. And the vinegar is an acid as well, so you can try and see what happens in there. You can see with nail polish remover. Try to do this at home, and again, you'll see the concept of what osmosis is, which is, again, the process where the solvent, which is your big liquid, is going to go into an area where there's no sugar to the one that there's a lot of sugar, and try to balance it. Okay, so I hope that you enjoyed this video. Bye. Okay, so what I'm going to try to do now is neutralize that nitric acid that I used for the gummy bears. I don't want to throw it away as an acid because it's not good. It's very concentrated, so I'm going to neutralize it with a base, sodium bicarbonate. And this sodium bicarbonate is actually baking soda. So I'm going to add some here, and we'll see what happens. Ooh, oh, okay. So you can see that what is actually, you see some bubbles? And what is happening right here is I'm neutralizing it. Those bubbles, this says sodium bicarbonate. So when if you look it up online, and you will see that it has a carbon and it has an oxygen. So basically what is forming when these two are reacting, we're gonna form carbon dioxide. And that carbon dioxide is those bubbles that you are actually seeing. So I can do this until I see that no more bubbles are forming. And you can see that the color of the nitric acid is going away. And this is pretty cool. Anytime you have an acid, anything at home, let's say that you spill some vinegar, or you have something else that is highly acidic, just get some baking soda, make a solution first, try to with water, and then just neutralize it with that, and that will be fine.